that sine 10 degrees is irrational. We know some common values of sine. For example, sine 30 degrees equals a half, which is rational. Sine 45 degrees equals root 2 over 2, which is irrational. Sine 60 degrees equals root 3 over 2, which is irrational. But we do not know the value of sine 10 degrees. We know 10 degrees equals 60 degrees, divided by 6. Or 10 degrees equals 30 degrees, divided by 3. So we could use multiple angle formulas to evaluate sine 10 degrees. Triple angle formula, sine 3 theta, equals 3 times sine theta, minus 4 times sine cubed theta. Now we let theta equal 10 degrees. Then by applying the triple angle formula, we have sine 30 degrees equals 3 times sine 10 degrees, minus 4 times sine cubed 10 degrees. Substitute sine 10 degrees equals a half in the equation. We have a half equals 3 times sine 10 degrees, minus 4 times sine cubed 10 degrees. Multiply the equation by 2, and rearrange the equation. We have 8 sine cubed 10 degrees, minus 6 sine 10 degrees, plus 1, equals 0. Now we let x equal 2 times sine 10 degrees. Then equation 1 becomes x cubed, minus 3x, plus 1, equals 0. This cubic equation is a polynomial equation with integer coefficients. By rational root theorem, we know that, if the cubic equation has rational roots, then they must be in the form of x equals p over q, where p is an integer factor of the constant term, and q is an integer factor of the leading coefficient. As both the constant term and the leading coefficient are 1. So possible rational roots of equation 2 are 1 or negative 1. When x equals 1, the left side of the equation is 1 minus 3, plus 1, which is equal to negative 1. When x equals negative 1, the left side of the equation is negative 1 plus 3, plus 1, which is equal to 3. So x equals 1 or negative 1 do not work. This implies that all roots of equation 2 must be irrational. That is to say, 2 sine 10 degrees is irrational. Thus, sine 10 degrees is irrational. The proof is complete now.